Hey, what's up, Clay? What's up, Justin? Big shout out.
You can restart it.
All right. So, the mean and standard deviation can tell you a lot about the sampling distribution. All right. We're going to learn how to calculate the mean of all the samples and the standard deviation of the samples. So, suppose that x bar, that's the symbol we use for mean on the calculator, of a simple random sample of size n, so that's the number, drawn from a large population with the mean, and that funky U symbol is mean, and standard deviation, that little curly Q, that's the symbol for that. So the mean of the sampling distribution, all right, so the mean of the sampling distribution, of x bar is this. It's the same thing, in other words. So the mean of the sample is going to be the same as the mean of the population. That's going to become key later on. It's the same thing. So these are equal. So when the problem tells you about the mean of the population, we're just going to move that on over and use that for the sample. It's not that hard. You just kind of make a funky U like this. It's just that simple. It's like a cursive U almost. I know you guys don't do cursive anymore, but standard deviation, okay, that's that funky little symbol there, is the standard deviation divided by the square root of the number in the sample. We're going to use that over and over. Okay, so a few things. The sample mean is an unbiased estimator for the population. Okay, so no bias involved. Standard deviation of the sampling distribution of x bar describes the typical distance between the sample mean and the population mean. The distribution of x bar is less variable for larger samples. So we've talked in the past about things becoming more precise as they get larger. So it becomes more precise or less variance. And last but not least, these facts are true regardless of what the shape of the distribution is. Whether it's skewed right, skewed left, normal, these hold true. All right, so we're going to do two problems here. And 1 through 4 of your homework look just like this. Okay, so we're going to do a couple easy steps here. Your homework is going to be based on this. So it says, suppose the true mean number of hair follicles on a human head is 100,000. Okay, so mean number 100,000. Mean 100,000. Make that connection. The mean is 100,000. Remember we said the population mean is going to be our sample mean. We use the same number. With a standard deviation of 40,000. Standard deviation. The mean number of hair follicles on the heads of 20 randomly selected humans will be computed. Okay, so it says calculate the mean. Remember, this is the same as population mean. Same thing. So we're going to do that funky looking U, x bar. What is the mean? What did they tell us in the problem the mean was? 100,000. Bam. 1, 2, 3. 100,000. There you go. Now, standard deviation. I did that wrong. Got my little curly Q in the wrong spot. Okay. So, curly Q of x bar, that is the actual math name for it, is, remember, the standard deviation, which is what? 40 grand, 40,000, divided by the square root of the number of in the sample. How many are in the sample? 20. Good. So we're just going to calculate that on our calculators. Yeah, why would you need a calculator for stats class? It's just silly. Who would have thunk it? 8944.27. That's it for that. Okay? That's it for that. That's all we have to do. And then we're going to interpret, as we always have, but this is a very easy sentence, not even a paragraph. On average, and we've already talked about this, what the meaning of standard deviation is. On average, find out, what are we talking about? We're talking about hair follicles. We don't even have to go that far. Just hair follicles, that's fine. Just hair follicles. We don't have to go on the heads of hair follicles. Then we say the word typically. Typically. Deviate from the mean. We talked about this the other day, that the standard deviation is how far it deviates from the mean. So it's always going to be deviates from the mean. From the mean. By about. And just plug in that number we found. 8,944.27. That's it. That's all you have to do. Very simple sentence to remember. Okay? It's going to be the same thing every time. On average, something typically deviates from the mean by about something. So really, this and that. That's the only fill in the blanks. Otherwise, on average, typically deviates from the mean by about. That's the statement. All right. Here we go again. The number of movies. Number of movies viewed in the last year by students in Large High School has a mean of 19.3. Mean. Standard deviation of 15.8. Key information. An SRS of 100 students. That's my N right there. We got what we need. So, what's the mean? Do that funky U with the X bar. It is 19.3. He's on it, folks. Then we do our little curly Q. X bar. That is our standard deviation. Very good. Over the square root of 100. Now, nobody needs a calculator here. What's the square root of 100? 10. When we divide by 10, we move one decimal.
To the right and left.
Left, one spot. 1.58. No need for a calculator. Okay? When we multiply by 10, it goes right. When we divide by 10, it goes left. And now here's our really complicated sentence. On average. Wow.
Oh, wow.
Number of movies viewed. Typically deviates from the mean. I can spell. Not really. Typically deviates from the mean. 8. By about 1.58. That's it. And that's 1 through 4 in your homework today that you will get done in no time. That's all you're doing. These 3 steps.
No time for Call of Duty.
Now, these 2, homework 5 through 6, going to have a couple more steps to them. But it's still going to be done in no time.
Sorry.
I know who you're is. All right. So, we're going to do a couple extra steps here. We're going to put together everything we know. We're still going to do the same thing. Local SPCA, the Society for Prevention of Cruelty to the Animals, feeds animal shelters, but the amount of food needed per day varies. Distribution of the weight of dry dog food is approximately normal. This is important. With a mean of 30 pounds, standard deviation of 5.1. Find the probability that the mean weight for 6 is randomly selected is greater than 33 pounds. This is extremely important. That has to do with our graph. We've been doing that all year. Okay? So let's all put it together. Number 1 is find the mean and standard deviation. Okay? Well, we just did that. So this is the same thing from the previous page. What's our mean?
Mean is 30.
Yep. You got it. What is our standard deviation? I did it again.
5.1.
Divided by square root of 6. It's 2.08.
Okay.
Okay? That's number 1. Number 2, we have to draw a curve and shade, but we need a z-score for that. So, z equals, remember, it's the actual value minus the mean divided by the standard deviation. Let's work backwards. What's the standard deviation? We just got it. 2.08. What's the mean?
30.
30. It's right above there. So we're going to subtract it from the actual value. What is the stated actual value we're comparing to?
33.
Yeah, see how we work backwards and we just find it? It's very easy. 33 minus 30. So when we do that, we get 1.44. So we're just going to come down here and make a very easy normal distribution like that. Easily drawn. We're going to go out 1 and 2. We don't have to do 3. We're just going to mark 1.44 approximately right here and shade. I'm not measuring. We're not being perfect. Okay. You could even, you don't even have to write that. You could even do this. Watch. Saw that. Boom. You could just say that's 1.44 right there. Okay. Now we go to our we go to our table A in our packet. Okay. And when we do that, 44 is going to yield the number 0.9251. Is that what we want? If we want greater than, if we're shading to the right, is that the number we use? No. What do we do? 1 minus. Anytime we see greater than or to the right of, we do 1 minus. 0.9251. That's a 5. Which gives us 0.0749. So for number 3, our probability is that, 0.0749, or 7.49%. That's, we're done. So in other words, there's about a 7.5% chance it's going to be greater than 33 pounds. That's it. That's all we're doing. So numbers 5 and 6 in your homework are going to be just like this. Okay, number 1 comes from the first page we just did. Number 2 and 3 we've done before. Let's do one more. At the Peanutty Peanut Company, dry roasted shelled peanuts are placed in jars labeled 16 ounces by the machine. The distribution of weights in the jars is approximately normal with a mean of love this board. A mean of 16.1, standard deviation of 0.15, careful with that. Mean weight of 10. We'll get to that. Okay. Find the probability the mean weight of 10 is less than the advertised weight of 16 ounces. Okay. So, 1. What's our funky mean? What's the mean of the population? 16.1. Okay? And then our standard deviation is going to be, well, what's our standard deviation going to be? 0.15, that's in the population. Divided by the square root of 10. Very good. So we are checking 10 of them.
And then we would use 16 for the number 2.
We'll get to that, but yes. Very good. So you should have gotten 0.047. Very good. All right. Now number 2, we got to find our z-score. Let's work backwards. What is our standard deviation? We just found it. 0.047. Okay. What is our mean? It's right here above it. 16.1. And what are we subtracting from? 16. Very good. Okay. So notice, is my standard deviation going to be positive or negative? Negative, because 16 minus anything bigger than 16 is going to be negative. And we get negative 2.13. So now we just draw our beautiful little standard deviation. We put 0, we put -1, we put -2, we do put -3 because, you know, negative 2.13, label it. Boom. Which way are we going, left or right? Left, because it says less than, doesn't it? When we go to our table for number 3, negative 2.13 yields the number, the area, 0.0166. Do we need to shade? I mean, go subtract?
No.
No, it's left. That's our answer right there.
Drive the script.
1.66%. Either one. You don't have to turn it to a percent. Either one. I'll take either answer. Okay? That's it. Now the homework, again, the first 4 look like the previous page. The last 2 look like this page, which incorporates the stuff from the previous page.
Woo!